Let's walk through a learning module in QuantHub's Applied Data Science course in Chapter 5. The focus is on analyzing the association between two quantitative variables using both visual and numerical techniques, a core skill in applied analytics, engineering analysis, and business decision-making. In this lesson, students will use visual techniques to analyze association and learn how to move from visual pattern recognition to precise statistical measurement. Instead of being asked to complete simple calculations, the problem is presented in a real-world scenario where students are challenged to justify their methods, compute a formal statistical measure, and translate results into analyst recommendations. Students are placed in the role of a statistical analyst, working with car engine and fuel efficiency data, using email-based simulations and team-based problem-solving skills. The lesson clearly defines the task up front, ensuring students have a strong understanding of the assignment's context and scope. Students begin by examining a scatter plot showing the relationship between engine size and fuel efficiency, measured in miles per gallon. Rather than jumping straight to a formula, they are asked to visually assess the direction, strength, and linearity of the relationship. This step develops analytical judgment. Students must describe whether the association is positive or negative, weak or strong, and whether it follows a linear pattern. Students can also download the data set in an Excel spreadsheet to follow along. Those who are interested have the option to explore the data in Excel, though access to Excel is not required to complete the assignment or work through the problem. Next, students must decide which statistical method is appropriate for measuring this relationship. They evaluate the data characteristics. Both variables are quantitative and continuous, and the scatter plot suggests a linear association. Based on this reasoning, students justify the selection of Pearson's correlation coefficient as the correct tool for quantifying the relationship. Then, with the method selected, students calculate Pearson's correlation coefficient using the clean dataset. They apply a statistical tool or spreadsheet function to compute a single R value that quantifies both the strength and direction of the association. Students must understand that this value falls between -1 and +1, and that its magnitude reflects how tightly the data points cluster around a line. The lesson then shifts from calculation to interpretation. Students analyze what the sign and magnitude of the correlation coefficient actually mean in context. A strong negative value indicates that as engine size increases, fuel efficiency consistently decreases, confirming and quantifying the pattern observed visually. Students also discuss important limitations, including the distinction between correlation and causation. Finally, students translate the statistical result into a real-world recommendation. In this case, the analysis supports selecting smaller engine sizes to improve fuel efficiency for a hybrid vehicle design, while acknowledging that other engineering factors must also be considered. Students are also provided with a recap of the skills they've learned and an explanation of how those skills apply within the team-based case study. Congrats! The assignment has now been completed. After completing the assignment, students are able to see which problems they answered incorrectly and understand mistakes. This lesson reflects the rigor of QuantHub's applied data science curriculum by requiring students to evaluate data visually, select appropriate statistical methods, compute precise measures, and interpret results within a real business context. Students aren't just learning how to calculate correlation. They're learning how to justify, interpret, and apply quantitative evidence.